And I would like to call right now my quite good colleague and friend who will give you the next paper based on this same problem, but with the name of influence of the glue-in reinforced profiles into the thermal characteristics of wooden window profiles. It's Barbara Šubic. Thank you very much.
So thank you very much for the opportunity. My presentation is connected to the presentation that Uroš held. We are both working on these reinforced big-sized windows. So today we'll see, I would like to show you how these reinforcements really influence on the thermal characteristics of the windows. Thermal characteristics are really important. Why? Because in modern buildings and in designs that we are doing now, energy losses, energy efficiency of the buildings are of most importance, and we all know that, let's say, 40% of all the energy losses in the world are made through the houses. But if we compare, if we already know how to make good walls on our houses, and in the low energy houses, this thermal transmittance of the wall can be as low as 0.15 with another problem, even if it's wood, brick, or concrete house. We have windows which are the best you can buy, let's say nowadays, that can go only till 0.7. And these are the best windows and also quite expensive. But if we go on averaged windows, they have values of 1.2 till 2.0 watt per square meter kelvins. So there is quite a difference. And on the same surrounding area of your house, you have a wall which is very thermal insulative, and you have a window which can be the best you can buy, but are still like 10 times worse than the wall. So this is something that we make quite a lot of attention to. And the second reason why we really should make attention how the windows are built are the condensation that can be built on the windows, and also condensation in a while leads to mold growth that no one wants to have in his house. So of course condensation starts when the right criteria are met: the internal relative humidity, the internal temperature, and the temperatures on the elements that are dividing you from the outside world, so the wall and the windows. These condensation are quite common in old buildings, maybe not as severe as this one, but you are all familiar with this kind of condensation. They are quite normal also in modern buildings. And this is molded growth in the corners. And when you are replacing windows in old buildings, this mold can be even worse, because with new buildings everything is airtight and the humidity cannot go out as it could before. And this is what happens. And this is not something you want to have. Modern buildings are built up by modern trends, and this is what the trend is going, where the trend is going all around Europe. So there are these are samples from different countries, and everywhere you can see that the windows are going from the bottom to the top of the floor, or even our customers want to have it through more than one floors. So what we really need to think of when we are designing new windows is this criteria. So outside, if we say outside temperature is -5 degrees and outside humidity is 80, inside temperature is 20 and inside air humidity is 50, the minimal temperature on the window anywhere should be higher than 13 degrees. If it is not, then condensation starts, and after a while also the mold growth. So this is the criteria when we are designing new windows, we need to take into account. These are the experiments that were done and that were showed also by Uros. And these were also the analysis that was done, the thermal analysis that was done on these windows. So how the reinforced windows, which really gives us stiff windows that could resist the high wind loads, how does these reinforcements affect on the thermal losses through the windows? This was the analysis that we did. So this middle part is called mullion, and it's the middle part here. And this is the part where we have enough space to put reinforcements in. So this is the part that we chose. The 4-point bending test was made so that we could see and estimate how this stiffness was improved. The different reinforcement schemes were pre-built, and these were the two samples that were also analyzed thermally. By thermal analysis, of course, the most decisive criteria is thermal conductivity of the materials that we use. On top is spruce. Spruce is the most common material that we are making windows of, which has the lowest, quite good thermal conductivity. Then in the middle we have glass. Glass is the biggest part, covers the biggest part of our windows, so it's very important. And glass fiber reinforced profiles, carbon fiber reinforced profiles, steel and aluminum are the materials that we analyzed as possible reinforcement materials. Of course, if you can see these numbers, aluminum would be the worst choice to take, but in the experiments we chose aluminum because it was the easiest material to use, just to get the knowledge of how everything is really working in the 4-point bending test. So it was also then included in the thermal analysis. Thermal transmittance of windows is calculated by thermal losses through the frame, thermal losses through the glass, and thermal losses through the edge between the frame and the glass. The bigger the window, the more glass we have, so the less effect has the frame, so the less effect has the reinforcements in the frame. There are different values of the thermal losses through the different kind of profiles that we use. And on the left, top, and right side, we have the same profile, so these values are the same. On the bottom part, we have different profiles, so also the values are different. And of course, in the middle mullion, the values are also different. The glass always used here was 0.6 glass. This is the triple glass normally used for windows nowadays. So, if you see this picture, the bigger the glass, the lower the U value will be. So, the bigger the glass, the bigger the window element, the bigger the glass, and the lower the values of the thermal transmittance of the whole window will be. These are the values that we've seen before. You can see that the glass that you can buy nowadays is at least 2 times better than the frame that you can get at the windows, and it doesn't matter if we have wooden windows, aluminum, or PVC windows. So the worst, let's say, the worst part of the whole window is a frame. If we now analyze the thermal losses, we can see that this is the width of the window, this is the height of the window, and these are the thermal transmittances that we calculated. The bigger the element, the lower the thermal transmittance, and the bigger, the higher the element, and the wider the element, the lower they are. This is a calculation made by normal windows that we do, so without any reinforcements. Then we've repeated the step and we've chosen the reinforcements inside with aluminum. So in the middle part we have 2 different reinforcements, up in the upper and the lower part, and 1 in the middle. And the thermal transmittance of this kind of reinforced windows is, let's say, for 10 to 20% higher, so worse than if we don't use any reinforcements. So we have some thermal losses that we gained just by using the reinforcements. But this is not really the worst of it. What we really need to think of is also condensation, as I spoke before. So what we like to know if this temperature, the minimum temperature on the inside is higher than 13 degrees or not. We've compared this analysis, thermal analysis. So in the upper part we have this middle mullion without reinforcements, and in the lower part we have mullion with 2 reinforcements up and down, or 2 reinforcements connected with 1 vertical one, which is of course the worst scenario, because then the transmission of the heat is also present. And we compare now these numbers. So the temperature, the minimal temperature in normal windows unreinforced is higher than 13 degrees, which is okay. If we add up reinforcements with glass fiber, it is already a little bit lower. If we add it with glass fiber and the vertical reinforcement, it's also a little bit lower. But that's, let's say, okay, the condensation will start, but we are just at the edge. In this case, we have used glass fiber reinforced profiles, which are quite good thermally insulated. But if we add carbon fiber reinforced profiles, the thermal conductivity of this is already worse, and also the temperatures are starting to get lower and lower. So 8.8 is it's already a very low temperature, and the condensation in normal winter will start for sure. If this material is replaced with steel, the temperature falls to 6 degrees. And if this material is replaced by aluminium, which is of course the worst material in this case, the temperature is only 3.3 degrees. What this means in real life? So here is also the comparison of the temperatures by different materials compared to unreinforced profiles. All of them, no matter which material we use, but if we have a reinforcement only in the upper and the lower part, the tolerances between them, or the difference, is 1 degree. But if we have vertical part of reinforcement, the differences are severe. So 13 degrees or 3.3 degrees by aluminium reinforced windows. In real life, this means that the 13 degrees, the minimum 13 degrees on the inner side is met at one temperature. We try to collect at which temperature outside these degrees is met by different materials. So if we see these are the only 2 inner reinforcements, and these have the 1 vertical ones. This is the worst case. If we have 2 reinforcements and 1 vertical one, the 13 degrees limit is met by aluminum reinforced windows already when the outside temperature is 9.5. 9.5 temperature, the lowest, can be met, 8 months per year. So in all this period, the condensation will start on the inner side. For the comparison with the referenced windows where there is no reinforcement inside, only when the temperature outside falls below -7, the condensation will start. So new modern buildings will be built, and new modern windows will also be built, and also high elements will be installed that will need reinforcements. And according to our analysis, carbon fiber or even more glass fiber reinforcements should be used, and of course no vertical reinforcements should be used to prevent these thermal losses or thermal transmittance through the windows profiles, and to prevent condensation on the inner side. So this was everything from my side. Thank you.